And welcome back! Today we are going to talk about 3D scanning and 3D reconstruction. This is Fireside Chat by Delta 3 Innovation Lab. I am Clemente Giorio, aka Tino Tinux, and before starting, let me introduce my co-hoster at Bad Crime, Gianni Rosagallina. Hello Gianni.
Hello Tino, welcome everybody.
And of course, let me introduce our special guest, Tim Porter. Hello
Hey
Tim.
everybody. How are you doing today?
Fine, thank you. So, before starting, please tell us more about your background.
Sure. So my career started about 15 years ago. I have a degree in computer animation and graduated from Full Sail University. After that, I did some smaller projects and scanning and cleanup capabilities, and then I kind of put that really behind me. I did a lot of work inside of studios as a artist, and then I became a technical artist. Anybody who doesn't know, a tech artist is kind of bridge that gap between code, art, and design, things like that. My focus, because there's a couple of different ways that you can be a technical artist, was on automated systems and on optimization. So I spent a lot of time building tools for the art team to make sure that their assets came out really good. An example I was told was one of the projects we were working on. The design team came in and they go, "We have 100-headed Hydra that we want to do." And then of course the art team, you look over and they're drawing cats, and then the dev team's already thrown a table. We can't make this happen. And so I would sit down with the art team and I would go, okay, what if we made a Hydra making head system? And they're like, cool. And then I would go over to the dev team and I go, okay, what if I made sure that all the assets went in this folder structure and we're super optimized? I'm like, great. And then I would go sit down with like the engineering team that was doing all the pipeline and process that was specifically for the engine itself, and start doing tests. And then by the end of it, maybe we wouldn't be able to get 100 heads, and I'd go back to design and go, okay, it's an 89-headed Hydra. Like, cool, we can write that in. And so building that relationship and that understanding between all of that was really important. Also, when I switched over to starting to work in the movie industry. So last movie I worked on was Alice in Wonderland through the Looking Glass at Sony Picture Imageworks up in Vancouver. And then after that, I worked at 2-Bit Circus with, so if you know Nolan Bushnell, founder of Atari, his son, Brent Bushnell, made this really cool project creation space, Steam Circus. Like, one day I'd be working on a comic book adaptation, and then the next day I'd be working on stuff with Raven Busters, like 3D scanning technology, like everything. And then I ended up starting my own studio, where we were doing XR for major corporations, and this company that I currently am at spun out of that, and that was for the want of creating content. How do you make content at scale? How do you make it easy? How do you make it optimized? How do you make sure that it integrates into everything from your next movie that is running on game engines now, all the way down to the new all-in-one VR headset, mobile phone, or maybe even, and I don't know if you guys saw this, somebody hacked a McDonald's kiosk to play Doom. So maybe the same assets there.
So we are talking about a different target, VR, video games, movies. What are the different approach for 3D scanning for those different targets?
Sure. It really kind of depends on the studio. It depends on if they want to go ahead and just focus on a single vertical. So you'll end up getting a studio that's an XR studio where they're doing just AR, VR, and they maybe will do some mobile work. Their need for quality of scan could be just as small as using a really good smartphone. Get an iPhone out there, take some nice scans, and then the magic kind of comes in optimization. But if you're at a major studio, like one of our clients is NBC Universal, so we do work, from these major scans that will end up being in a movie all the way down to something that they're going to have in a headset. They take their scans at really high level detail. You end up getting not just, scans with the DSLR. you'll also get things like LiDAR, which are, laser pointed scans, and we end up combining those together. And then we will send them assets that will be optimized for all of the different playback systems that they want to utilize it in.
Very cool. We experienced with footage from a drone to reconstruct a sport venue, and also with Kinect, the depth camera by Microsoft. Very, very cool and easy to use. But of course, we are thinking about the next level, and it is not easy because, first of all, the detail of the model.
Oh yeah.
Maybe a million of polygons. How to manage it? How to optimize it?
Oh yeah. So I mean, this is a problem that has obviously plagued scanning just in general for a very, very long time. Quite often when we do large scale scans, they will be in the billions of polygons. 1.2 to 1.5 billion is not uncommon to run through our systems, and we end up having to make those things run on something as small as a cell phone. And so there's a lot of solutions that go into that. We tend to focus on things that allow for the most artistic freedom, creative freedom, and ability to go back and finalize if there's a change that's made. Since my background was very specifically working in pipelines and process at studios, I kind of know what ends up happening, when you end up making these assets. That 11th hour, someone goes, it would be nice if, and these idea fairies, they always come out, and they just like float around and go, let's do this. And so you end up having, everybody knows how that works. And so you end up having to make sure that the assets are available for that. So, chopping up assets into large assets, blocks, so that they can be optimized individually, being able to make sure that you have snapshots along the process. If you end up having this really nice, and it's got all of the secondary maps, and then it's entirely optimized, but that little piece needs to be cut out in there, it's got to jump back in the process. And if it's got to jump all the way back to the very beginning, that can be days worth of time, even on servers. So if you create snapshots in between, then it allows people to go, oh, this is in the place in the process that I need to go ahead and do my fix. And then it can be thrown back in and then optimized down. What you want to do is take obviously a lot of the nasty parts off of people's hands, so that you end up having artists be able to do artisty things. But you also want to be able to make it to where it is as flexible as possible. It's a give and take between ease of use, flexibility, and capabilities. So,
what are the most common problems with 3D scanning? For example, I'm thinking about shadows, reflections, different light exposition.
Yeah, that's fun. So photogrammetry, if you're talking about just regular 3D scanning, shine, sheen, refractive. So think about something like a glass, mirrors, thin objects aren't good. Even down to like somebody with a brim of a baseball hat. Not usually good. People's hair, different situations like that. And so those things end up having to be reconstructed again. If you're talking about LiDAR, you can get a lot of the same things. You can get like self-reflectance back off of something like, a mirror, or, if you're outside a window, something like that, you can end up creating laser scatter, which causes issues and things like that. But there are a lot of solutions that people are working on. We're heavily working on this, obviously in the world of things like machine learning algorithms. Anybody who has been paying attention to Instant NGP, which is NVIDIA's new Nerf product, it's a wonderful solution. Nerfs have been around about 2.5 years now, late 2019, early 2020. They came out. There's a lot of negatives that go to Nerf, but it's going to end up being a future. So the idea is, instead of creating so photogrammetry works like this. You take a whole bunch of photos around an asset, Then it does this thing called a sparse point cloud and understands where the cameras are in three-dimensional space. So it makes little dots based on its understanding and its interest of the images, and goes, cool, I'm going to put all these cameras around. And then it does this thing called a dense point cloud. You can also do it in the depth map, but it's the same kind of concept. We'll stick in with one idea that's a little easier to understand. So it does this dense point cloud. So basically, then it shoots out all these rays into a center point. If anybody knows trigonometry, you're just making a bunch of triangles based off of here's a camera here, and here's a camera here, and there's a third one. And so it does this over space. And then you end up making a mesh out of it. And then, so very simplifies the concept of the process. Instead, when you're talking about machine learning algorithms, what it does is it starts to understand what the space is and end up having to fill in the gaps between the space, its understanding and its lack of understanding. And it also has much more tolerance because it's built into its own scene for things like shine, sheen, reflective, and objects, glass, and things like that.
Usually, we are talking about 3D scanning for like a photo, instant photo of an object, a person, maybe an environment. But it's also possible to scan adding the time dimension, like a video, a movie.
Mm-hmm. Yeah, volumetric video, holographic video. There are a whole bunch of different ways to go about it. Companies like 8i, when they started out, so 8i, if anybody doesn't know, they were kind of the first, we'll say, commercially viable. They were the first commercial version of volumetric video that you could kind of pick up off the shelf or go to a studio and kind of go into and do any sort of volumetric video capture on. The really cool thing about volumetric video, like you're saying, it's over time, so you can end up seeing people in motion. Anybody who's done any animation or things like that, if you guys have ever watched an animated movie, if you look at like frame 1, frame 5, you're like, wow, that's messed up. But as it's over motion, it ends up looking fine. So you end up being able to get away with some really lower quality assets that come out. But the really cool thing is, and going back to what 8i was doing initially, is they were taking things like webcams and cameras and syncing them up to go ahead and do recordings like bullet time around everyone. And so they were doing these scans around objects and people in motion, and because the frames were in sync, it was basically photogrammetry over time. And so you end up going, an OBJ sequence and all the way down. We end up doing our own volumetric capture recording where I end up being able to sync webcams starting in 2017, early 2018, where we were doing scans. I think the first one's of me, so it was about 4 years ago now. And then we end up creating larger and larger arrays and rigs and things like that. And we've also worked with other people's cameras, arrays, and rigs. Because you're talking about photogrammetry, when people sit down and they're like, here, we're scanning, and they end up having these rigs that are set up for digital doubles. If anyone's seen a digital version of somebody, that's just like somebody sits down at this giant camera array. So a bunch of cameras that are already around them. They end up switching them from photo to video mode, and we were doing holographic videos with people in places and things. So.
Just to clarify to our audience, when, for example, to scan a person with this approach, usually the person, the guy, enter in a room with diffuse illumination and many cameras that are synced that shot in the same moment the person. This is the easy part. The more complicated part is then to optimize the model.
Process it. Yeah.
We are talking before in the cinema, for example, I would like to watch the detail on the skin, but in a video game it is not necessary for an avatar.
Yeah, I mean that's 100% true, and avatars are a little bit different. You know, if we're gonna like volumetric video to be used as avatars is not necessarily the most attractive situation, because you think of volumetric video as 3D video. And so making changes to that 3D video is something that, you know, the industry is working on. But I think right now we're sitting in a crossroads between a bunch of different technologies. I think right now we're sitting in the world of, do you guys remember VCDs at the same time that Blu-ray came out, as the same time as DVD, HD came out, and there are a whole bunch of other players? We're kind of sitting at that crossroads right now when we're talking about being able to do 3D scanning of any sort. And so there are a bunch of technologies that are going to make, and there are a bunch of technologies that aren't going to make. And I don't believe that volumetric video in the way that it's currently being done will be made, because being able to go ahead and scan somebody who is at a stage with these massive limitations, like we talked about, tons of cameras, they normally are absolutely super expensive. If you're talking about something like, you know, one of the reality capture studios, or one of the, oh yeah, let's talk about, you know, any of the Microsoft stages, millions of dollars worth of equipment. If you're talking about the Intel stage that they had, it was absolutely, it was so cool. So I ended up going to the Intel stage, and they painted it white, and it's this giant open area that was big enough, and I'm not kidding, to bring in things like elephants and cars, and like you have the space shuttle in there, like absolutely giant area. But the way that they painted it, and the way that they did the sound in the dome and everything like that, when you walked onto the floor, because it was so white and it reflected light, you didn't have a shadow. So normally when you look at your arm shadows itself, and you get this self-reflectance and things like that. That didn't happen in that stage. So you'd go in there because they didn't want you, they wanted to light it like really, really well. And they didn't want to have to do like lighting cleanup and stuff like this. So they built the physical stage to go ahead and do that. It's super weird to see yourself without shadows in real life. You're just like super trippy, and you get like this weird vertigo kind of situation, because you can't really like figure out like what's going on. So that one's an interesting one. And so that one had, and I'm not kidding, I think they were saying it was something like 80 terabytes worth of data was going through every minute for the cameras and things like that. It's really, it doesn't make any sense. There's no reason why you would require all of that data. If we're looking at the stuff that's coming out, there are things called Nerfies, which is Nerf, where you take a camera and you can move your face around. They also have volumetric video that's the same thing with limited inputs, and they're doing things like regular cameras, or they're using cell phones that they all turn on the cameras at the same time, and they have like 5 or 6 cameras at the same time. Those style, I think, is going to be a lot more useful. Or if you go towards what Google and Facebook are doing, and Facebook actually, I just released this not too long ago, where you can make a MO version of yourself, where you just take a couple of photos, and then it ends up doing all of that. And you know, once they get a little bit better, obviously the telltale parts, humans, and talking about like Uncanny Valley, and we need to know, there are 2. We'll start off with the original concept of Uncanny, and then we'll talk about the secondary concept of Uncanny, because it actually goes against some of the stuff that we talked about earlier. It's really interesting. So the Uncanny Valley is this line of realism based off of a static object. So you have an object, and how realistic it is. As it becomes closer and closer towards what looks like a human, it becomes very, very realistic up until a point. At a certain point, it drops absolutely off the charts, all the way to the bottom, where people are like, that's not real. You know, and obviously there's some interest in like, how did that happen? Is this like evolutionary, where, you know, we were around other things that weren't quite human, like Neanderthals and all of that at the same time, so we had to know that they weren't us, and so those things are bad and causes this level of disgust? Who knows? But there is 2 separate charts, and the second chart is the one that Facebook is very specifically breaking. The first chart, it looks very real. It doesn't move, and you look at it like, wow, that's a people. But the second one is the movement. So there's a different chart that shows how movement goes. So if you look at something like a prosthesis, someone's leg that has been generated, it can look absolutely amazing, and then it starts moving robotically, and you're like, whoa, that's not real. And it causes this level of disgust, and that's some of the things that you end up getting out of these new Facebook algorithms that are out there. Beautiful and wonderful, but they're missing a whole bunch of little micro and macro details. These lines, these wrinkles. As you notice, as I'm talking, I actually have blood flow changes. You can see in this area, there's less blood flow. And as I become more static, these areas start, and those little bitty details are obviously extremely important. And we pick up on as humans naturally and natively because it's just part of our brains. But when they're not there, we notice them. But when they're there, it's everything is normal. So that goes to basically anything. You talk about sets where our company's focus is really, the large is amazing, making these giant sets and all of these scans. But think about the 90,000 assets that are in the background of any given movie. If you need to make a digital version of them, they have to be really good and they have to be there. But if they're not there, you're going to notice. So it's just fun how human perception works, just in general.
It's a really interesting this point of view of a perception, because of course if we don't require this detail, but we can reconstruct with the model with the AI with less detail, we of course with less effort we can build a scene. So the role of AI. We saw here the role of AI for optimization, for the animation of the model. So maybe we can talk about a different strategy to scan, for example, a person, optimize with AI. These allowed to don't have many cameras, and then use an AI to move like a human.
Yeah. I mean, so, going across the board, there's a whole bunch of really cool things that can happen even in the reconstruction world. And we're working very heavily on specifically making it to where reconstruction is easier, or capture itself is easier. So, I mean, people want to think of the asset from there on, and even just setting up a camera. So, that first comment that we had was someone's got to go to a studio, and then the lights have to be like this, and then the assets have to be like this. I can't wear a lapel, or my hair. Often they end up doing things like skull caps and they put the hair on later. And so if you end up making some algorithms that are really, really good at being able to take these cameras that right now they're using, very, very high end. Some of them like IO is absolutely the best. Like, give you an idea how good they are. They're on the International Space Station. These kind of guys. Those are the kind of cameras that are being utilized right now to do volumetric video and do holographic capture. What if you could get away from using a $8,000 to $16,000 camera, and you could use a lower end camera? And so we're doing algorithms right now for white balancing, exposure control, degrain. We have degrain, denoise, deblur, and being able to make these really low-end cameras look like they're high-end cameras for the quality, so that when they're put into an algorithm, they look great. And then you end up getting into that next section where we're talking about this reconstruction. Obviously, our current reconstruction techniques, when we're talking about photogrammetry, are cool. They're great. You can do a per frame sequence and you get some really good stuff out of that. What if we could do a low end number of cameras, low end quality cameras, and then you can get this nerfy like volumetric capture where it ends up infilling the data. Cool. Then you end up getting that asset out. And then now you have to do something with it. So those assets have to be polygonal, because they have to be polygons, because they have to run through our game engines and our engine sets. So then you have a wonderful mesh. And then what? You have an overall texture, a single thing. game engines do a lot of really good things to recreate the world, but the shaders and the way that they do that and the way that the engines do it, it's not that bright. It needs help, and it needs help with things called secondary maps. You get in secondary maps, most people have probably heard of like a height map or a normal map. You end up getting albedo, gloss, metallic, specularity, specular fall off, refractivity, occlusion, transparency, translucency. These are all different maps that need to be generated to recreate a really amazing asset. Obviously, you need every single one of them for every single use case, and then every single situation. But those things need to be generated, and so there are tons of machine learning algorithms we're working with NVIDIA right now to extend what those capabilities are. Being able to take the photo of the output, which has what's called diffused light. So you end up having, even if you light it nicely or you don't light it nicely, there's shadows. I have self-shadowing capabilities like we talked about with the Intel stage. What were they trying to do? They're trying to make self-shadowing go away so they don't have to worry about converting that self-shadowed asset, which has its own native lighting. Even if you're talking about diffused lighting where it doesn't have lighting, you have to remove it and bring it down to an even look so that it can be picked up and put into a bunch of different games and movies and things like that. And it's got to be relit so that, if I'm thrown into the Sahara, I have to look like I'm in the Sahara, or the next 5 minutes I'm in the Arctic, I have to look like I'm in the Arctic. So stuff has to be done to that initial texture that comes out. So you end up doing, and we're finalizing right now, diffuse to albedo. Albedo is that same thing where all that lighting information is taken out, all that sheen, everything like that, this flat color output. And then you have to add in all those things that you took out, but you have to do it in a neutral manner. So we have things like making normal maps, being able to go ahead and create specularity, which makes the shininess, all of these secondary lights, as you see as I move my face around, you get the shine pieces on them. That makes me look realistic. Even reflectivity, and people are like, where's the reflectivity? Look at my headphones on the other side. I'm in a flip mirror, sorry. There's reflectivity that's happening here and specular fall off. And each and every one of those things, if it's not there, you're going to notice it. But once it's there and you do your job right, nobody will ever see it. And I think that's obviously extremely important for being able to create these things. But each one of those maps also need to be optimized. So you end up having to create really good algorithms that also do things like resizing. So people always think of resizing where we're talking about super sampling. Super sampling, you say story and machine learning algorithms all day long. You got to make the image bigger, You know what happens when you go smaller? There's something called either bicubic or quadratic sampling and things like that. Basically, I have a line and then I make that line half the size. It will go ahead and take information from this side of the line and that side of the line and then shrink it down, and then it'll go ahead and blur it and smudge it. Obviously, that's not a really good idea often when you're talking about these really minute details. And then you end up getting weird things like this gingham pattern that I have on my shirt would be absolutely impossible to go ahead and deal with if you didn't have a machine learning algorithm. This shirt very specifically is considered not television safe because they have sampling capabilities that are in scan and just regular cameras. So it'll end up doing weird things in the pattern of advance and things like that. So machine learning algorithms go through and help clean that up and then deal with that. And then the very last bit of that is mesh optimization. So being able to deal with the mesh itself. You can go a whole bunch of different ways. Right now, a lot of the answers that we have really kind of surround putting it into a mocapped character. So anybody knows about mocap, you end up taking a single version of the asset and then you put points inside of it that are called rigs. The rigs kind of get moved around based off of information. You can actually take that information that came from the volumetric video to go ahead and make this mocap surface. You go on that. There is a whole bunch of work as well right now to, instead of being able to control, basically you have on a face maybe 120 some odd points depending on what studio you're working at. being able to control millions of points. So if you think about, if I have a head that is, my face is 1.5 million, polygons or points, being able to go ahead and animate all of those points based off of the input information that we got from the volumetric video. So as I go smile and brown and things like that, being able to pull that in, obviously some massive trickery has to happen, because as you guys heard, when we do a scan, it just creates it based off of all this information. And computers do what they do, and they do it over time. They do what they do over time, every single time. So you end up having to do some massive remapping trickery back to single assets and things like that. So, optimization from beginning to end is a massively overhauled, very difficult process that can cost a lot of time. And as you guys hear, it's really technical. There's almost nothing that I talked about that was artistic other than the practical application of art and the technical. And so obviously a lot of the work that we do is trying to make tools that make it easy for artists. I think artists really want to do the art the way that they want to do it. And, my career was sitting down with artists, and one of my favorite thing is, and this is always fun, we used to have them, they were called Tim Days. Like, oh, am I a Tim Day? Basically, what I would do is I would shadow an artist. I would just pick someone randomly. When I'm stuff's slow and I'm like, all right, I've kind of built all my tools, and I know that these tools right here either have to get trained or there's something like that. So I take my roller chair and I just sit down and see what somebody's doing that day. And like, how many times a day do you click that button? Like, a lot. I'm like, sounds like a tool, and things like that. In the end, when you give an artist amazing tools and amazing pipelines, sometimes they'll do it faster. Most of the time they don't. Most of the time they'll really hone in on what their skill and their capability is, and they'll just make the most amazing work. I think that's really what we want anyways. I think that's what everybody wants. I think it's what every 2 years, 5 years, someone's like, look at that, it's so realistic, I can't tell the difference. And then you look back at it, you look back at some of these movies that came out and you're like, whoa, that was bad. And then you look at where people were doing, what's it called, where you do a review on it and they're like, most amazing graphics of all time, and you're like, oh yeah, see what happened there was but that's the way it works, right? How do we make things more amazing?
I have a question. You
Sure.
talk about a lot of topics, a lot of technicalities in artistic side. How many people, how many different role of people are involved in such a situation, in such scenario?
Sure. On average, when we're talking about a studio, there's about 13 hands that tend to be traded around when you're dealing with stuff. You end up having, if you're talking about a character, it would go everywhere from initially design would go to production would then go to concept would then go, if we're talking about a movie, it would go to casting. If we're talking about a game, it might go to casting, or it might go to 3D concept, depending on how large the studio is, or it might end up just going straight to modeling. And then from there you would go, and remember, every single studio, it depends. You get people who wear multiple hats, things like that, and some studios do it differently. A lot of times the concept artist will also do like initial texture maps off of the characters and things like that. And so if you're a character, it might go straight to a character modeler, it might go into a blocking modeler. From there, it's probably end up going to a rigger of some sort. So being able to put that rig into there and then move with the animation. And that could be its own thing. So to give you an idea, like SBI, there was an entire department that was devoted to just the animation of the assets, and it's not just the animation of it. We're talking about like pipelines and tools and integration and things like that. Like my specific job was pipeline, technical artist, intermediate, the animation department. And so it was just like, and yeah, of course that fits on a couple of lines on a card, a little bit long. But yeah, that whole thing. Then from animation, it'll end up, if it's a movie, it'll go to lighting, and then from lighting, it'll end up going to rendering, where you get the secondary look. It could go back to texturing, where the concept artist does it. Or at SBI, we had dedicated texture artists that would just sit there and do the textures. In a game studio, at that same split, instead of it going back to lighting, it would go to the engine department. The engine department might have some lighters. It might also just be the engine guys, not the people who build the engine, but do the integration for the engine that would be doing the lighting that's on that. And then you would end up having it go to a build process of some sort, because if you're in a game engine, then you end up having to make those secondary maps, and like you end up doing baking of lighting, and you may get ambient occlusion that's in there, or glow, raycast lighting, things like that, to be able to create the bounce lighting and things, and that all gets rendered and done. And then the movie studio, yeah, would end up going into the rendering department. And those are both the traditional workflows. Now there's new workflows. New workflows are things like virtual production, and everyone is now converging on the same thing. So this whole process happened after the shoot. And so now all of that process happens at the beginning. And so they end up having to do all these scans, all these assets, and all of these things. So like sometimes when we work with studios, we have a mobile tool. And this mobile tool, they'll send out, interns or temps or something like that around the city, and to try to figure out, oh, we need like this hat, or we need this thing. And they'll go out there and they'll scan this thing, and they'll send it back to their soup, and their soup's like, yeah, go ahead and buy that. We need this for this next shot. And then we'll take it back to the studio, and they'll end up doing the scans. But all of this stuff has to happen before the talent gets anywhere near the set. Because when they're there, sure, the DP and producer and EP and all of that stuff, end up getting the chance to go ahead and make these changes, but they're all done in game engines. So that means it has to be ready, it has to be optimized, it has to be cleaned up, and to be on set and on scene, because they are using, anybody knows virtual production, anybody watched Mandalorian, LED walls, background screens. There are mid-level capability and lower-level capability studios that are still doing it with green screen, but they're using a lot of the same tenets. That is, throw everything into a game engine, and then everything is lit all at the same time, and everything has all of these interactions at the same time. It allows for movies like Avatar. If Avatar, at this point in time, was adjusted for inflation, it cost about $238 million back when. Adjusted for inflation, it would be just under 400 and some odd million dollars, or just over $400 million. The next Avatar movies, each one of them are coming out under $250 million today's money. And so you're talking about $130 million per movie cost. I mean, that's a whole nother movie. That's another big budget movie that we're saving and changing this way. And so it's super important. It allows for more creativity, but it also makes for changes at studios. So the thing that you were saying is, like, how many hands does this go through at different studios? Now when we're working at studios, it had been, I would be working with each one of these different departments to go ahead and give them the assets they needed in given time. But studios, especially very large ones like Universal, had this idea of, like, why don't we just have a team that manages assets? Well, that makes sense, especially if you're talking about, let's deal with archival stuff, with maybe Brendan Fraser's hat from The Mummy and something like that. Like, it has to be managed in a way, and it needs to be the same way studio-wide, because you have to deal with licensing and the way that look happens, because basically a studio is built off of the way their look is. A Warner Brothers movie looks like a Warner Brothers movie, a Disney movie looks like a Disney movie, and so all of that has to be treated a way. And so we're dealing now with what would have been 13 to 20 different departments. We're dealing with one person who's in one department, who is managing it, and I'm not kidding, all the way from the this is what's going to be in the movie. Here are all the different assets going to be part of that movie. This is what's going to be on the marketing of the movie. Here are all the assets for the marketing. This is the VR assets. These are the game assets. These are the mobile assets. These are for these teasers and trailers. And so they'll pick it up and they'll go, boom, this one asset just gets split out. And like we talked about, optimized for each one of these different use cases. And it's one team that accepts it and just like, which is great. You know, it kind of saves us a lot of time, but it's a huge change for how the market used to work to how it is now.
And related to just to clarify, which are the tools to start with, or which are tools that you can use to work on?
Yeah. So we can talk about open source tools, and then we'll talk about what their industry
Commercial,
standards.
yeah.
Yeah, commercial. Industry standards, commercial. Always. There's reasons for that. I'll go over that. So, if you're talking about open source, you have Mushroom, photogrammetry, scanning. You can use your phone. There are a bunch of really wonderful phone scanning helping tools. If you don't know how to scan, we have the Mod 3D scanner to actually teach you how you want to set up your cameras and where you want to put them and where you want to set up the array. It actually forces you, using augmented reality, to put your camera into the correct place. So that way you know how to do it. I don't see it as an end-all be-all, and I don't think, when it comes to mobile scanning, being prescribed any given way of scanning is good. And that's something that most scanners do. Obviously, we're teaching you how to do that. It goes up to our process and it goes through. And so, for mobile, if you're going to be using a cell phone, going into something like Mushroom is great. It can do all the photogrammetry assets. Once it gets out of there, you're going to use something like Blender and GIMP. Both really good asset tools, and they'll end up doing the optimization and the cleanup for you. Obviously, with GIMP, you're going to have to do a lot of work to get secondary. But there's a whole bunch of old school techniques. I think anybody here who's on the call or is watching this later and wants to know, like, how do we make these secondary maps? You look at game information from about 2002 to 2008. There were a whole host of, like, how do I make an albedo map? How do I make that? And there are, and I know this is going to be the most Ben Coward end up making a whole bunch of like how to do this kind of stuff, back when. And then there's things like X normal. If you want to go ahead and do things like texture reprojection, make normal maps, you go from a high resolution asset to a lower resolution asset. There's X normal that does it on your individual object basis. There are also really cool things like MeshLab. MeshLab is great if you get really big assets with point clouds. Cloud Compare is out there as well, if you want to go ahead and do that. I would recommend, if you're just starting out, very easy pipeline is definitely go ahead and use your phone, scan them, figure out what you can do and what you can't do, or use our app to go ahead and do that, to figure out how you do your scans. Go into something like Mushroom. If you don't use our uploading tool and you wanted to go ahead and just run it through, and then into Blender, and then from Blender into GIMP for finalization, and then X normal if you end up doing multiple levels of detail. Sorry, Crazy Bump. I said X normal twice. Crazy Bump is another amazing tool to go ahead and get texture quality, normal maps and secondary maps and things like that. So if we're talking about what would be professional grade, or pay for play, your typical would be like a DSLR, and then you would end up doing processing in something either reality capture or Androsoft Metashape. Both of those are really great. Capturing reality from reality capture is Epic Games, and Androsoft Metashape has been around for absolutely ever. Phenomenal, amazing tools. Between the two of those are pretty much the best. If you're doing something that is like drone related, some of the guys like Open Drone Map and stuff like that. But you're going to get some of the most amazing quality out of either of the two that I spoke about before, the image shape or reality capture. I don't really touch either of those. I don't see why you would want to. Out of that, doing something like Maya is great, handles really well. Excuse me. You can also go into something like Houdini.
Yep.
Houdini is wonderful. I love Houdini. I am also a coder and a very technical person. Anybody who's watched the chart of like understanding, they're like, and here is Maya, and here is Blender, and then here is Houdini. and then once you reach the peak, all you've done is realize that you figured out the program itself. It goes up from there. Houdini is a very difficult program. I love it. But then again, that's, I specialize in pipelines, which that's what it is. It's a really cool pipeline tool. Those are really good ones. And then of course, Photoshop. And then if you're wanting to do things like people, Wrap 3D is really awesome. That's from Russian 3D Scanner, the name of the company, and they are the industry standard when it comes to texture remeshing for stuff like doing rigging and things like that on humans and assets like that. And then of course, when you're talking about secondary maps and reprojection, even on the pro level, XNormal is super common. I still also see some people who do like crazy bumps and stuff like that. If you're talking about games and you just like need some secondary assets very quickly. But yeah, the XNormal is kind of, it's weird because it really hasn't been updated since I think the last time they updated it was like 2016, but people are still using it. It's just because it can handle absolutely massive amounts of like assets and it can do so much. Obviously, it could use an update, but most of the reprojection systems really haven't caught up yet. It's really bizarre. And then, of course, on professional level, you can get to some massively esoteric things, CG, GL, and things like that, where you're dealing basically straight in code and weird libraries and stuff like that. So, it depends on which side of it that you're on. But if you're talking about, small, medium-sized studios, they're going to stick with the ones I talked about.
Let me share a comment by Dever.
Sure.
Very interesting. So, from this comment, I think that the people now are starting to understand that we are at the tip of an iceberg.
Oh, yeah.
Because in this sector, we need a lot of knowledge, not a lot of tools, a lot of budget. And from the other comment, yes, and we need a lot of passion.
It's true. Okay, so what's the next one? With title called 3D Scanning and Reconstruction. What reconstruction is in this context? That word caught me as I ran parallel with the reconstruction stands for Photogrammetry. The title of this call is 3D Scanning. Okay. What reconstruction? Okay, I'm sorry. I see what you're saying. So reconstruction that we're talking about is generation of a three-dimensional asset, just to let people know. So if you're talking about typically, and this is where this divergent thing of what's happening right now, if we're talking about things like machine learning algorithms and NERFs and things like that, it is basically a wave function. So it is three-dimensional, but it's only three-dimensional based off of things like view dependence and things like that. So things of showcasing based off of what angle is being viewed and things like that. Versus the flip side, where you're talking about like photogrammetry or even really much video, where you end up getting a polygonal asset. You're talking about an actual 3D asset that can run in a game engine on your phone. Actually, anybody who has a Windows machine, if you double click on any 3D asset, it'll actually open up in the Windows 3D viewer. You can watch it, look at VR headsets and things like that. Obviously, a lot of work could go into being able to utilize a NERF or NERF-like object, which is just machine learning algorithm. for the inside of a game engine, that would be awesome. Obviously, all the information is there. I would expect that there are major companies that are possibly looking at making that happen. Game engines might be doing that right now. Who knows? So.
About the game engine, what is your favorite?
Oh, it depends on what I'm doing. For me, what do I like to use the most? If I'm trying to get something together really quickly and it doesn't necessarily need to look amazing, but it needs to be, like we talked about, I like Houdini because Houdini has, there are no rails. The rails are what you make of it, which is great because that's what I want to do. I just want maybe not to have to set up everything. So it's setting up my environment and things like that. Unity's amazing for that. Being able to go ahead and get under the hood and almost immediately affect absolutely everything. If I don't want to build it, I can probably go on the asset store and for like $50 get absolutely everything. Like that you could absolutely cobble together entire games and projects and everything without like really doing too much by buying it on the asset store. And so it's one of those really amazing things where you get this ability to do everything you want, but at the same time, you don't have to if you don't need to. Unreal, if you need to make something beautiful, Unreal does it, and it does it in spades. It's absolutely always been beautiful, amazing. It's easy to get going. Quality-wise, artists love it because it's got all of the tools that you would expect. Something down to the point of, here, let me double-click on this asset. Okay, what's the material that's on it? What are the textures that are attached to it? Let me look at it when I drop it in a physics simulation. And literally creates its own like little scene. You can look at it, okay, what happens when it flows? Okay, what happens when it does this? And it's all right there. You don't have to leave the engine. You don't have to do anything. And Unity's done a whole bunch recently to try to make that something that they're focused on, and a lot with their acquisitions as well. As you know, Unity ended up purchasing Weta, and so let's see what comes out of that. One thing that's obviously really interesting is, there's always a joke in the industry. It's like, oh, it's the Weta way. And the Weta way is always because Weta always did it away. They made their own version of, you name it, all the way down, So the term, oh, we're going to do it the Weta way means that you just put it together for right now for your specific problem. And so it almost goes at a dichotomous nature versus what Unity is and what it attempts to do. Unity attempts to make it to where it's this open, flourishing capability. And Weta is like, no. Line. We are a line. You go in, you go out. It stays like this. So let's see what happens there. And so one thing that we did skip over, and so now we're talking about studios and tools and things like that, is why do major studios use professional tools on a regular basis? Why is, and when everybody says, let's use Blender, why that is something that's terrifying. That really kind of comes down to every single time there is a new iteration of things like Blender and other open source tools. There are massive changes almost always to things like the API. There are huge deprecations and even within like dot product releases where you're like, within 6 months, they're like, this is the initial release. Now we've changed the API that's on that. I had code that was from like 1996 that would never change while we were at SPI. Like that, and that's important. That's very important because going, oh, we've now done an update. This is not, as much as it's software development, it's not software development. You can't expect like an Apache patch to change. You know why? Because when you want to go ahead and make a tool that all it does is counts the points on a face, does it really need to be updated because the software got updated? No. Give you an idea, Photoshop has not been updated in its core, the core of Photoshop, since Photoshop 3. Photoshop 3, that was in the 90s. The core has not been updated, and they add new features, they build on top of it. And the way that they work, deprecation is not very often had. Unity has kind of broken that mold where they do make these changes and there are these updates and things like that. But then again, they're also not very well known for being at large studios. Once you get above 50 people, it tends to go to Unreal. And so it's a very big, or they'll do their own engines. Yeah, we had our own engines. I could tell you so many stories about game engines. We had an engine at GameLoft. Oh, this was a fun one. We had an engine at GameLoft that was nicknamed Glitch. It was called the Phoenix engine, but we named it Glitch because it was super glitchy. Like, for example, I was working on a particle system for one of the Cars games, and whenever you hit save, it would crash the whole engine. And so I sent in a bug report, and you know what they did? They made it to where the save function didn't work. They shut off this. That's all they did. They're like, yeah, it's okay. There's an update. And I'm like, you guys are screwing with me, right? Yeah, this is the thing. So what I did was, I'm not kidding, I'd have to write down all of the things that I made changes on. Like, okay, here's that. They're like, oh, I want another particle system, but it's like this one. And I'm like, cool. They're like, but I want a little bit more of that. I'm like, all right. And I'm like, all right, here's the page, and then I put all of the 50 different parameters and like tune this one up and down. They're like that. I'm like, yeah, okay, cool. And then export it out as that thing. But that's, yeah, that's the reason why it was called the Glitch engine. And then there was a internal memo of them telling us that we weren't allowed to call it the Glitch engine anymore, that we had to call it by its name, the Phoenix engine. And then we end up coming back the next day, and somebody had put this in the men's room. It was a drawing of this Phoenix that was like half burned and like not coming back to life. It was like this zombie Phoenix. And they're like, the Phoenix engine. And I'm like, yep, pretty much.
my final curiosity, there is something like Git for the assets, because I'm thinking that the assets before the optimization, in the middle of the optimization, will be saved. But we are talking about huge files, so there is some things like Git as a repository for the assets, or no?
I mean, it depends on the studio. Some studios are doing that, and we're working with major studios right now to make that something that can be more ubiquitous. So companies like Technicolor have been for a number of years making it where you could go ahead and purchase from them previous scans, but every major studio does have some form of like visualization thing where you can take a look at different shots and different assets that are in there, having things like model views and stuff like that, where you search for any given thing, and it's not just the asset. They're super cool. You can go all the way down to, I want this rig that was on this different shoot and these kind of things. And there would be times that they would have already been kicked off to archival, but you'd have like a small snippet backup, and then literally like the system would go in and like pull it off of tape and like, bring it out. And then, 3 days later, you end up getting your asset and you're like, no, I meant version 2, and then 2 days later you end up getting that asset out. And so a lot of that, I mean, when we're talking about the advancements where we're going towards nerf and stuff like that, that's going to be really good. But yeah, I mean, that's something for the future and for another day. So yeah, it's going to be constant.
Okay, we are at the end of this Fireside Chat. If anyone wanted to leave a comment as soon as possible, we will try to answer you. Thank you, Tim. Hope to see you again in another Fireside Chat. Thank you.
All right.
Thank you, Tim. Very, very interesting. Thank you. Have a good day.
Thank you. Bye.
All right, bye-bye.
Bye, bye.